In this lesson, you're going to learn to simplify complex numbers. Our essential question is, how do I simplify square roots with negative radicands? So perhaps you've seen this before. Take a second and see if you know what this means. By the end of the lesson, you will. So we define an imaginary number as a multiple of a quantity called I, which is defined by a property that states I squared is equal to negative 1. So if I squared equals negative 1, if I were to get just I, well, I'd have to take the square root of both sides, which means I is defined as the square root of negative 1. So that didn't exist in the real number system. We always said that it was just non-real, but now we're going to go into another numeric system. So we always said the square root of negative 4 was undefined, but it does exist in the imaginary number system. So I kind of want to show you the pattern of how this works. So as you look at these, you know that the square root of 1, well, the principal root is 1. And we just said the square root of negative 1 is defined as I, or I could even say 1I to help you see the pattern here. Square root of 4 is 2. Well, the square root of negative 4 is 2I, because we could rewrite the radicand as negative 1 times 4. Square root of 4 we know is 2, and the square root of negative 1 is defined as I. Square root of 9 is 3, so the square root of negative 9 is 3I. The square root of 16 is 4, so the square root of negative 16 is 4I. Okay, so the first one on your note guide says square root of negative 81. Well, hopefully you're seeing the pattern that this is the same as negative 1 times 81. This is equivalent to I. Square root of 81 is 9, so this is best written as 9I. Square root of negative 50. Well, again, I can rewrite this as negative 1 times 50 by the product rule. Square root of 50 is irrational, so I'm going to break that down with a factor tree, circling my primes as I go. And I'm looking for pairs. I have a pair of 5s, so the square root of 5 squared, the 5 comes on the outside, the 2 stays on the inside, and the square root of negative 1 is defined as I. So I write that as 5I root 2. You will occasionally see this written as 5 root 2 with the I at the end. Just if you write it like that, make sure it's super obvious that the I is not under the radical sign. So this one is going to be square root of negative 1 times 72. And again, 72 is irrational, so I'm going to break this down into my primes. 8 splits into 4 and 2. 4 splits into 2 and 2. So I'm looking for pairs. I have a pair of 3s, so the square root of 3 squared is 3. I have a pair of 2s. Square root of 2 squared is 2. I have a leftover 2 that stays under the radical sign, and then the square root of negative 1 is I, for a final answer of 6I root 2. Try this one on your own. Pause and check your answer when you're finished. So I broke this down to 5 times the root of negative 1 times 192, and now I'm making a factor tree for 192. You should have done the same. Check your primes to make sure that they agree with mine. Remember, a quick check to make sure you've factored correctly is multiply all your primes back together, and you better get what you started with. Okay, so I had the original 5 on the outside. I'm going to draw my square root sign. I'm going to put the I out right away because I know the square root of negative 1 is I, and I'm looking for pairs. So I see a pair of 2s, so I'm going to have times 2. I have another pair of 2s, so another 2. I have a third pair of 2s, and I have a leftover 3 that stays under the radical. So this becomes, multiply your coefficients back together, 40I root 3. Now, a good check on your calculator, well, your calculator can't handle the negative radicand, but if you just typed in 5 root 192 and ignored the negative part, and 40 root 3 into the calculator and make sure you get the same decimal, you'll at least know that you simplified the numeric portion correctly. So if you look at my graphic organizer here, You know real numbers. We focused on that in this unit. That was your natural whole, your integer, your rational, irrational, all made up the real number system. Well, now I've just introduced you to I, and I is an imaginary number. So pure imaginary numbers are like I, 2I, negative 2I, 5I, 7I. But when we start taking one part real and one part imaginary and put it together, it makes up these complex numbers. So complex numbers are in the form of A plus or minus BI. So here's an example, 3 plus 2i, 5 plus the square root of negative 15 is not simplified, but it is technically a complex number. So what we're going to do now is I give you different expressions and you're going to simplify it as a complex number. So I'm going to begin with this part right here, the square root of negative 36. And 36 is a perfect square, so the square root of that would be 6i, this portion right here. And I'm just going to bring down the 12 and my minus sign, 12 minus 6i, and really you just kind of think about, are they like terms? Well, this one is real, this one here is imaginary. Nope, I can't combine them. Just like you couldn't combine 12 minus 6x, you can't combine 12 minus 6i, so it is simplified. This one right here, 13 plus 2 root negative 15. Well, I'm going to start by simplifying the second portion right here. The 2 is on the outside, and I can break up negative 15 into negative 1 times 15, and 15 just breaks into 3 and 5. There are no pairs, so the best I can do is bring the I on the outside, and root 15 stays on the inside. I bring down the 13 and my plus. So this is 13 plus 2i root 15. You will also see this written as 13 plus 2 root 15i with the I last, but again, I caution you with that because if you wrote it 2 root 15i and it looked like the I was under the radical, that would be wrong. So I think I prefer this top method. Try number 8. Press pause, check your answer. So hopefully you've brought down the 19 minus 8, and then the square root of negative 9 is equal to 3i, and since the 8 is a coefficient, it's held by multiplication, I'm just going to put a times sign there. Order of operations, I'm going to multiply, and I would have 19 minus 24i, and that is simplified. Here are 3 additional expressions to simplify. Press pause and then check your answer. Here are the answers. Please reach out if you have any questions.